service-oriented architecture. So we want to talk about service and what are some of the essentials about SOA or service-oriented architecture in this chapter. So first of all, this is divided into four sections. First, defining what service is, basically what's the service, what's the service description, and how do you communicate with services. Next one is what is SOA actually. Then we talk about some technologies using web services. And finally, we'll talk about SOSE, service-oriented software engineering. So these are the basic topics we'll cover in this chapter. So first of all, let me create a quick analogy. Service-oriented architecture it's like cooking at home versus eating out or ordering from out. When you cook from home, you have to go buy the items, follow the recipe, fix the food, and then you eat it, and then you clean after yourself. Versus service-oriented architecture, it's like going to a restaurant. You simply pick what kind of food you are going to have. Just go to the restaurant or call and get the food. So if you go to a restaurant, you don't worry about who bought the ingredients, what description or recipe they followed. They just provided it. So this is exact analogy we do. We did sort of normal software engineering. We actually follow this paradigm, whether it's agile or whether it is a waterfall. So you basically have some requirements, then you go through the design, and then you implement, and then you got a system, boom, you release it. That's like going to the grocery store, coming up with your recipe, which is designed, then cooking it, which is actually implementing it, tasting it and eating it, and putting it on the table, which is releasing it. Now, as opposed to, going to a restaurant, that's a totally different recipe. You do not do any of those. You actually buy as much as possible from outside. So in coding or implementation of the system, you go to open source to see what's there. So most of your system is actually comprised of many other people's work. Some is open source, some is part of your own company for reuse, and some of them actually you purchase yourself, right? So that is the sort of the difference. So the key thing becomes really more focused towards service. So we buy some cloud services, buy other things, buy source code. So when I say service-oriented architecture, it's a natural follow-up to component-based architecture, which means how do you design the system in components? Now let's go get the components. I need a payment. I don't want to write it. Let's get some payment from there. I need to do a login. I don't want to write it. Let's get it from there. I need to sort numbers. Let's get it from right there. So all you have to do is glue them together. It's your system, but really you put it together. So it's more of a service oriented. So kind of like, so now we need to discuss what is a service and how do we distinguish with service. So think of an Italian restaurant analogy. So restaurant provides a food. So it's a service, right? After the order is taken, food is produced. So you go there, order some food, they produce it, serve it. So service may consist of other services. So even though it's the food, but it probably has, salad, soup, other things. So it consists of other services. Now the menu indicates a service provider. So you look at the menu to pick. So that's a service description. So you go to a restaurant to order a service, but you have to have a description of the service, which is the menu. Now the order is communicated or written down, communicated with the waiter or waitress. So this is a communication. This is service communication through some messaging. So the cook does not deal with you. You deal with the waitress or waiter, and they communicate your desire to the cook. So that's the communication. So now we're talking about three things here. We talk about service, service description, service communication, extremely important. So for service-oriented architecture, this is the fundamental thing. The rest is how to come up with these things. So what's the service? Okay, I want to buy things online. What is the service description? Here is the stuff, okay? Add it to your shopping cart. What is the communication message? Press send, press your credit card. Amazon will get your service and deliver it to you. Everything. Your electric bill is the same thing. Your shopping online is the same thing. Your ordering a system is the same thing. Okay. So we talked about this already. So the main ingredients is service, service description, and service communication. Now, communication typically is done in computers in two ways. One is shared memory, which means I write in a piece of memory, you go read it, or we send messages. Well, this is a distributed system, so we don't have a central place to write things. So we use messaging. So really, then we have service, service description, service communication, which is done through messages. So implementation through web services or internet, right? That is what provides this. So another example, let's say a citizen is looking for a house or rent an apartment. So what do you usually do? You check the personal data, you know, information from a system X. Then you check tax history because you want to know, is this person kosher? Do you have enough money? Do you have, history of receiving paychecks, etc. Okay. Then I check your credit history because you're not gonna buy for $500,000 house cash. So basically, what do? We're gonna lend you the money. The bank is gonna lend you the money. So basically, that's we check your history, and then we also search rental agencies just in case you could not afford it. We could rent it for you. So based on that thing, we provide that for you. So that basically, I will say, to provide a service for you, sometimes you need to do other sub services. You want to buy a car, therefore you need to be able to finance the car. You need to be able to trade your old car, right? So these are all sub services. So what's a service? Extremely important here. It's a platform independent computational entity that can be used in a platform independent way. Notice I cannot repeat platform independent anymore. A service is platform independent. When you rent a movie from Netflix, it doesn't matter, are you watching on your phone, Apple computer, your PC, or you're actually connected it to a huge, theaters, or a stage, right? So these are usually callable entities or application functionalities accessed by messages. So you download things typically using messages, and components are capable of performing a task. So this is often used in connection with something we call it SOA, or service oriented architecture. I want to watch a movie, here's your movie. So it's really a shift. So the whole thing is from producing software to using. Remember when I was talking about the cooking analogy? In cooking, you're involved with actually producing it. You produce your food. Now I'm going to be actually a user of the food. I'm just going to order that food. So you need not to host the service or keep track of the versions or anything. At a restaurant, you don't need to know who's the cook or where do they do their purchases. None of that. This is just the way it is. You need not to sort of make sure even what the evolution of the system is. Software is somewhere and it's deployed as a service as needed to you. This is called software as a service. I need this thing, give that to me. Okay. So these are the key aspects of service. There are about 10 of those that I'm going to go over in a second. I have a slide for each one of those. So basically, how do you discover a service? I mean, if I need to find a plumber, or if I need to buy a good payment or a stock trading system, there might be many of them out there. How can you find it? Let's say if you need to, and this is sort of an analogy, you need to find a good restaurant. There might be 15 of them near you. How do you find it? Well, you go Google it, you go search it. Well, the same thing for our services. Right? Remember, you're trying to build an application together, so it's not as easy to Google that anymore. So how do you find it? And a few more things. How do you make services reusable or autonomous, things like that? So I'm going to define this. So please remember this slide, but I'm going to individually, instead of reading through it, I'm going to go one slide or two slides for each one. First thing, service discovery. That's the very first item that I showed you on the previous list, right? So this is service basically to be discovered, right? How do you, this is extremely important one. This is almost the most important thing. There's a restaurant. It's important for a restaurant for you to know where it is and also for you to find it, or a plumbing company or a payment routine or a sorting routine. You need to be able to find it. So it's extremely simple. Here we have 4 components. 3 are in red boxes and the rest are arrows. Okay. One thing is, first of all, the service provider, let's say it's a plumber. What do you need to do? You need to publish things about yourself. Oh, this is Khalili's Plumbing. My address is this thing, and my office hours or my business hours are from 8 to 5, Monday through Saturday. Okay, so this is your information. So it's metadata. You don't need to give a lot. You just enough for people to find you. Okay, I do payments. I trade stocks. Okay, here's my information, my contact information, etc. So, but you need to publish it somewhere. So we call this registry, kind of the yellow pages. So I'm going to publish my service. So it's going to be ABC Plumbing, or this is ABC Trading System. So you publish. Now, as a requester of a service, you need to find people. So the first thing is you go to the registry. It says, hey, I'm looking for a plumbing. Is there one available near me, right? So basically, you look it up. You might have 2 or 3 of those, okay? And then you select one of them and you click on it. So you bind to it. So first, you look at it and you bind and say, okay, bind means communicate between those two. It's as simple as that one. This is actually the fundamental basis for every search you do on Google today, or everything you look for is really this way. Somebody has registered themselves. When you simply go Google something, what are you doing? You're not going to this plumbing company or to this payment company or this Twitter shop. You go to a registry somewhere or multiple registries, and then you find their information. And of course, you see a lot of clicks or links to different places. So you pick the one you want. Maybe there is, you search for, anything about UML or anything about this movie. You might have 15 different links. You pick the second one or the third one. When you click on it, you bind. It's kind of like, I look for plumbing. Now there's 5 plumbing companies come down. I want to pick the second one because it's closer to my home. Or they are open Sundays and I'm looking for that. That's the one open. And then you click on it and you bind, which means now you have a communication and you go with this one. Okay. So service discovery, let's think about the same thing, rental agency. Okay, you are trying to rent an apartment. So first of all, there needs to be a rental agency one. Okay, they come here, what do they do? Okay, so basically they come and publish themselves to the registry. It says, hey, I'm rental agency one. Okay, now rental agency two comes. There doesn't have to be just one plumbing or rental agency, there might be many of them. Okay, number 2 comes, you publish 2. Now registry has both of them. Okay, now you are a consumer, somebody who wants to rent it. So maybe a municipality, city, somebody who rents apartment, or maybe a university who wants to find a place for you to live. What do? I go to the registry. I don't know anything about the agencies because I only have access to the registry. Okay. Now, after a little bit, when I search for it, I have some criteria because there might be 100 different rental agencies. I want something that's immediately open. Right now, I'm renting for now, and I want it cheap. I want it to be less than $800, for example, right? So it goes there and searches, and of course, it's going to bring back agency one to you because it fits your criteria. Okay. Now, what do? You contact agency one, and now you're connected to them. As simple as that. Everything we do on mobile or on the web, which is all internet based, is done using this type of service discovery. Now, okay, now rental agency communicates back to you and you have the bind. You know what happens if for some reason you click and the rental agency doesn't respond? You click on the second one. So the buying is kind of like calling someone now that, so I'm looking for a plumber. In older systems before internet, what would you do? You go to your yellow pages. So some places they actually call the registry the yellow pages of web. We'll talk about it in a second. So you looked into, and they're plumbing P, and there's like 9 of them. You pick one, and then you bind to it by calling them. And if they pick up, make an arrangement. If they, or maybe you pick up and you don't like their arrangement, maybe they are too expensive, or the next opening they have is a week from now, you go to the next one and you bind until you want the one you want. Done. Okay. So service discovery has to be dynamic. That means all that stuff we do, every time you have to repeat it, because what happens, you cannot say, well, last time I looked for it, it gave me that kind of information. I'm gonna use cookies and register it, because that is pointed, because each innovation may select a different one. Maybe yesterday when you search for something, it gave you one. Maybe it's since yesterday. Maybe last time you searched for it, there were only 3 plumbing companies. But yesterday a new one came. That's why it's important for you every time to renew this one. So the primary criteria if selection is the contract. What are you looking for? I want an apartment, I want it immediate, I want it cheap, or I want a plumbing company that's open Sundays and within 20 miles of my home. So whatever is in your contract, what you want to do this one. So selection may be based on workload, complexity, anything else you are going to do. Maybe your selection is which one is the cheapest, or which one can come to my home to service me faster, or which movie is on sale on a Tuesday, right? I mean, whatever it is. So if answer falls or takes too long, go to the next one, select another one. Like if you call the say plumber A or to Netflix to get this movie and you don't get it, then go to another service. Okay. So is discovery really new? Many design patterns basically loosen couplings between classes. So it's been around for a long time, but we are actually making this one very session-based, dynamic as we want it. So it's called factoring pattern. Create object without specifying the exact class of the object. So pretty much this is called loosely coupled. Every time we form these things. The fact about this is we shouldn't have any pre-notion about our previous call. Remember, let's say you were trying to buy a house. At this point, you put your information, it gathers your information, but your credit rating is low because you're a student. You haven't, made a lot of money. You don't have a lot of credit. So the system should not remember this thing. We talk about this. Should be a stateless, because what if 5 years from now you're working for Google and make $200,000? Now I don't want to say, well, 5 years ago I was poor, so what? So that is what's important for us to be sort of stateless in a way. Next one, service can be composed. In other words, services can be building block for other services. So there's not different from basic component software engineering and other approaches. So for example, you say a vacation package. Let's book a vacation package. Well, vacation package means rent a car, means airline, means hotel, means, tour buses, means tickets to see sites. So even though the service is book a vacation package, bodies consist of many things. So often is this, like when you want to go to something, there's a lot of other things might be involved. I want to buy a car, so that's a service. But then it requires other things. I want to, exchange my old car. I want to be able to finance my car. I don't have cash. So financing these with now a bank versus selling your used car requires a used car division of the same place. Okay. Now services have to adhere to a contract, right? Everything has to have a contract. Contract is between the provider and the receiver, or publisher versus the requester. Like exactly when you go to a restaurant, right? They have a menu with the prices of the food. That's a contract, right? It's both ways. From the restaurant, they tell you this food, so they're supposed to give you this food. You're not gonna order beef and they give you chicken, right? You're not gonna order salad and they give you soup. Exactly what it is. That's that part. So they have to satisfy the end of the contract. What about yours? You have to pay for it. They say $20 plus tax. That's what you need to pay. Same thing with all the internet services. What is my contract? So request to register should contains everything needed, not just functionality. Okay, for example, when you try to rent an apartment in the previous one, it shouldn't just say I'm an agent to rent an apartment. It has to have other information. I want an apartment, I want right now, and I want it to be less than $800. Maybe rental agency, I know you're a bona fide agency, but you don't have what I'm looking for. So that's really important to keep that in mind. You need to be able to satisfy my request. If you don't have an apartment, let it go. For example, if you call a plumbing company and you book for the next 2 weeks, don't let me pick you. because you say my availability is short for now. Okay, so for normal component match is implicit. A lot of these things we don't have to specify, it just goes without saying. So platform characteristic, quality, tacit design, tacit decisions means things that goes without saying. Okay, for example, if I request to rent an apartment, okay, it of course goes without saying there needs to be some kind of a two-way commitment. Okay, you can't say, well, I'm going to rent an apartment from you, but at any time I can rent this apartment to somebody else. No, this is tacit information. We do this one. Or when you rent a Netflix movie, Netflix gonna let you watch this movie for 2 hours. It's not gonna say, well, I'm sorry, the network is too busy. I'm gonna stop and not show you the movie. So a lot of things is just tacit. It just goes with it. Okay. So quality of service is very important, or this should say QoS, not QoC. Okay, QoS is just a typo. Quality of service means you have to guarantee to a level of quality for me. I cannot rent a Netflix movie, pay for this one, and it's very choppy. Okay, or I cannot rent for example, apartment and the door is broken, or plumber who doesn't know what they're doing. These are the same thing. When you go to a restaurant, you expect them to give you the food that's edible. I'm sorry, I'm like your brother. I don't know how to cook, right? That's not gonna go. So these are stuff quality of service. Of course, quality of service is a very, very sort of variable thing. That's why ranking becomes important. For example, if you go to this restaurant, at the beginning, everybody has the same rating, but after a year, people start getting more stars to this one because it's a better quality, lesser price. So at the beginning, they all had the same level, but a year later, this one has much higher ranking than the other one. And you tell Google, when I search for this service, tell me the highest ranking ones first. This is called ranking algorithm. Ranking initially is the same, but after a while, you could say, well, go to the website that has had the highest hits or highest view from the people. So we often, at the end, we have what's called SLA, service level agreement. That is basically the agreement where we go. A lot of times these agreements are tacit. For example, when you rent something from Netflix, it goes without saying, I have to pay, you have to show me the movie. We don't have to spell it out. But sometimes you have to be very explicit. What do I mean exactly by this service? Okay. When I tell you you could come watch a basketball game, I'm not guarantee you sit on the front row. I'm guaranteeing you have a seat anywhere there. So these are some of the things that SLA needs to spell out for you. Okay, so think of once again service-oriented architecture right there. This is the way we did this one. So when we did this one, it's really important for us. The information goes there. This important thing is immediate, is cheap. Okay, because all the other ones might be the same, but the fact that say I want immediate and was cheap, both of these have apartments, but maybe agency two doesn't have something that's cheap, or doesn't have something that's immediately available. So services needs to be loosely coupled. That means rental agencies come and go, no assumptions possible, stronger than component based. Okay, that means don't tie things to things. So loosely coupled. If I wanted it, it's there. If I don't want it, I don't want to use it. Like I'm not going to say, well, there's an Italian restaurant next to my house. Every time I want Italian food, I gotta go there. No. Maybe today I want to go there. Maybe next week I don't want to go there. Same thing with services. Okay. As you can see, sometimes you go online and you want to pay for your information or things you download from Amazon. Sometimes you want to use Discover card. Sometimes you want to use your Visa. For example, Amazon says, no, 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 Khalidi, last time you used your Visa ending with 9. No, I don't want to use it this time. So this is called loosely coupled. It's up to you what service, what day, and you could change your mind. Okay. Yesterday I came to your restaurant, I ordered a steak. Today I want to order fish. You can't say, well, no, yesterday you ordered a steak. You must always order a steak. No, this is whether maybe today I want to come to your restaurant and order coffee only, right? So this is the way it is. It's very loosely coupled. It's there. Service is there. Service description is there. It's up to me, and my request today might be different from my request from yesterday. Okay. Services have to be stateless. As I mentioned before, rental agency, for example, cannot retain information. It does not know if and when it will be invoked again. So do not remember things about me. I went to buy a house today, I didn't qualify. Don't say that information, because 5 years later I am a millionaire, and then you're gonna say, oh, this guy is poor. Okay. So the key thing is status. Every time reissue one, reevaluate me again. When you go to your rental agency, you cannot say every time I go there, give him rental agency one because he gave me a cheap and available, because maybe tomorrow they don't have it. Maybe there was a last apartment that was cheap and available. So that means the next time also ask the same question. This time maybe another rental agency can satisfy. So it has to be stateless. Stateless means what? Do not remember anything about the past. Do not assume anything. Do not save anything. Pretend this is the first time I'm dealing with you. Okay. Services have to be autonomous and hide their logic. That means, for example, rating agency has its own rules on how to structure its process. Its logic does not depend on other services. So that means if you call something a service, it has to be a totality. It has to be standalone. I don't believe it's kind of like when you rent it, when you buy an airline ticket from American Airlines, it should not keep other things in place. So, well, I'll only sell you the airline ticket if you go to the Hilton Hotel in Hawaii. But since you're not going to Hilton, no, this has nothing to do with it. It's autonomous. I'm only purchasing my airline ticket with you. You cannot tie things together. Okay? For example, I'm going to admit you to the university only if your daughter comes to the university too. No, what does that have to do with these things? So that's why it needs to be autonomous. Autonomous is complete by itself, an entity by itself. An airline is just an airline ticket. It has nothing to do where you're going to stay, what hotel, where you're going to rent a car. So this works both ways. Outside does not know about the inside and vice versa. Okay. So that means I should, when I go to, buy an American airline ticket, they should not worry about where I'm going to stay. Okay. And I also should not know if American airline also owns the Hilton Hotel. So this goes both ways, because this might affect me, because what if I stayed at the Hilton and I didn't have a good experience? By the way, Hilton is a great chain. I love Hilton, but it's just as an example. But then I'm not gonna use American Airline because it happened to own American Airline. No. So this has to be both ways. Okay. Of course, services are reusable. That's the whole purpose of this thing. Okay, so we can always go ahead and reuse service models as a business. Okay, so not very fine grained. That means don't not very fine grained. That means don't tie it to things. Let's say I have a service which means sort numbers. Okay, the service should stay as sorting numbers. Don't say, well, the numbers only should be student grades. No, it could be elevation of an aircraft. It could be financial markets of a company. It could be grades of a university. A number is a number. So it should be reusable, but it should not be fine-grained. Don't define it. Oh, only give me the numbers that have something to do with financial markets. No, sorting means bigger numbers first, smaller numbers last, or vice versa. Right? But nothing about the nature of it. Okay, so otherwise it's not fine. If you do this is a very fine grain. Then you have to call it something else. Oh, I only sort numbers for financial markets, or only sort numbers for school. But it is going to be much, much, much more restrictive. So deciding on proper granularity raises lots of debate. Okay, to what level do we look at it? It always is. It's easier said than done, but it is always to keep things small and reusable for anybody who fits that purpose. Okay. Next one, we should use open standards. Okay, there's a lot of standards which I'm going to talk about it. So proprietary standards don't. When you develop a service, don't say, well, all these services should be written in Microsoft technology, or all of them should use Intel chip like PC, because that defeats the purpose. You write a service that it is on any language, on any computer. That is what's a platform independent, right? You can't say, well, if you are going to use my payment, you better run it on a PC. No, I want to buy your payment and use it on a PC, and then I want to use it on a Unix box, right? So there are lots of open standards which we talk about. A lot of them based on actually we talk about XML, which I'll talk about it. The key thing is you want to make sure services can serve as many people, as many places, as many platforms. When I say sort numbers, I sort numbers. I'm not going to say or sort numbers on Unix only, or I only sort number for that are related to the university. Sorting means sorting. So service facilities are interoperable. Okay, so basically means because of open standards that we talk about, okay, we have to have explicit contract and loose coupling. That basically means you should be able to have interoperable items. Think of it when you buy a Sony product, it should easily work with solo speakers and should easily work with Samsung TV. You can say, oh no, I'm so sorry, this speaker is only tied to Sony products. Well, then defeats the whole purpose. You buy this thing because you want it to interoperable with other services. I get your sorting routines because then I want to run it on a different type of platform and I'm going to use it for a banking application. Doesn't really matter. So a lot of classical notice, I use a lot of component-based software engineering, and we covered component software engineering before service-oriented because one of the fundamental parts of service-oriented is components. You need to be able to make this component, like payment is a component, login is a payment component. So when I have independent components, then I can make a service-oriented architecture. I can get your component and that guy's component and this guy's component and this open source component. It's like a Lego, and I put them all together. Boom, I have a system. All of a sudden, I don't. Like, let's say I have a party at my home. I don't want to cook, so I can ask an Italian restaurant and a Persian restaurant and an ice cream shop and a sweet place and then a cleaning service, all of them at different services. Cleaning people come clean, the food first services delivered, and a different company delivers desserts, another service company comes cleans. So these are all sort of interoperable. You can also, well, if you order this food from Italian restaurant, you cannot use this service company to clean your house. No, because that's the whole purpose. So interoperability between organizations are extremely important. Like we talk a little bit about this one, basically enterprise architecture or business to business. Business to business is when you have different businesses. I worked many years in B2B. Business to business is when you mix different types of businesses. For example, you work in car industry, but at the same time you want to be able to use banking because why? Because banking is actually finances your cars, right? Or you also want to work with auction systems because for example, let's say you are, XYZ Toyota shop. When somebody brings you their Jeep, you don't have license to sell Jeep. I mean, Jeep is a Jeep. So what do? You need to be able to sell this car on an auction to other people. So that is B2B. Now, I was part of the ABC Auto Shop. Now I'm connected to a Chase Bank, and I'm connected to these Dallas City auction services, right? So these are a lot of interoperability that we have. So far we talked about what is service description, and service communication, and I also showed you different type of properties of services: service independence, autonomous, service should be stateless, how do you discover services. This is part of the first bullet. Now we are going to devote the next 10-15 minutes to service oriented architecture, to actually how do I have, now that you know what is a service, how do you write it down or description, and how do you communicate it using messages, and what are the different types of idiosyncrasies with services. Let's see how can I build a service-oriented architecture. Okay, after that one we talk about some web services. So here, let's first right now discuss some web services. Extremely important, okay? Web services means what kind of services is it available to me to use it? Okay, first of all, implementation means to realize services. I mean, it's the whole thing. So everything we do in service-oriented architecture today is based on XML, okay, extended markup language. Okay, why XML? Okay, remember we used to have HTML and other things. XML is platform independent. For example, let me use an analogy which I've used before. Let's say uh, all of us are in an airplane, and all of us, we sort of, our airplane landed an emergency in an island, and we cannot take off for the next year. And we all speak different languages. Okay, you speak Chinese, I speak Persian, you speak, Indian, you speak English. How do we communicate with each other? We have to come up with an scripting language that it's not English because it's a full language, or Chinese was difficult, and people are not going to learn a full Chinese or English. So we come up with a markup language, but something that everybody respects and everybody accepts. And the things you want to communicate, how to say hello, how to say goodbye, how would say hunt, how would say fish. Okay, this is XML. So in computing, remember just a few things you want to do: send messages, receive messages. Now, what is in the message could be any language, could be a Java code, it could be a piece of C sharp, but the send and message should be in XML, because if the receiver and sender, let's say a Persian is writing a message to a Chinese, okay, as long as we both understand the send and receive messages, what's inside the envelope doesn't matter, because that's not my job. My job is to take this package and give it to you, right? So everything is written in XML. Now, XML is too complicated to write pieces of code, right? So we need to come up with different ways. So today we have four types, okay? SOAP, WSDL, UDDI, and BPLA4WS. These are the technologies we sort of use. And main standard bodies are either in OASIS or W3C. These are places or libraries or standards we keep it. So first of all, SOAP. It's called Simple Object Access Protocol. They also call SOAP message in a box. Remember when I showed you the discovery, we had triangles and a lot of arrows. Those arrows or communications are basically done in SOAP. They're basically the postal service. This is how you send messages and receive messages. It's written in XML, except a send might be 10 XML lines. So we could say, well, when I say send, execute this little subroutine called send or receive or encrypt or decrypt or record or log. These are all part of the XML. No, it doesn't really matter. Is this from a Unix box running Oracle to a PC running Microsoft Access? I don't care. I understand everything, right? So this is called SOAP, so communication between the different ones. Now, WSDL, remember this consumer and producer, they use WSDL. These are sort of web service description languages. How do I publish my results? And then the consumer, how would I look for an agency that has an apartment? So this is what kind of code. So you could say search database based on this, or publish my results, or insert into database or registry based on that one. We call this WSDL. Then we have UDDI. This is the actual registry. We also call that one Yellow Pages of Web. Please remember, I'll give you an exam question on this one. Which one of them is called Yellow Pages of Web? Is UDDI. It stands for Universal, because it's all over. Description, because you describe your services. Discovery, because the requester can discover, and then you integrate all your information. And of course, this last one, business process execution language for web services, is just a lot of additional APIs that we do this one. So we are slide 24. Let me go here and tell you really briefly here. Okay, so here, if I look at here, let's take a long time to get there. Okay, so I use UDDI for here, for your web services. I use WSDL for these two boxes, and I use SOAP for these. Now I need, so these are the four technologies I told you. SOAP, or message in a box, because you want to send messages. UDDI, because it's just like a giant Excel sheet. You need to say, hey, Khalili's Plumbing, here's the address, here's the phone number, okay? Or Netflix movie called, Pulp Fiction, $3.99 Tuesdays, here how you get it, right? WSDL says, okay, please insert my information into this UDDI. How do you do it? You write WSDL, very simple XML-based code. And this is also, tell me everyone who has apartments of this price. Okay, and finally, you have a couple of business libraries if you wanted to do more things. For example, let's say if you wanted to find the best rating, okay? For example, you could say, hey, you know what? I have 4 choices for plumbers. Which one has the highest rating? Then you could use this business-based library to say, hey, let's compare all of this information. So these are basically the type of technologies that I told you before. So please remember, this is not a coding class. If you take a software engineering coding class, this is what we practice. We actually build this. In this class, you just need to know, and this is very important. All of these are based on XML. Why XML? Because XML, extended markup language, is a scripting language that is platform independent. An Oracle box understand XML, a PC understand XML, a mainframe understand XML, a mobile phone, Android understand XML. Everybody understands XML basically. So XML a little bit on it. So I'm going to have a short description on all of these, just very quick. It's like HTML. It's language. It's scripting language. It's only syntax. That's not a lot of semantics. There's not a lot of meaning. It's just send, receive, translate, or encrypt, decrypt, things like that one. So there's a lot of, we call it semantic webs or Web 2.0, which has add semantics, okay, like WOL, etc. But for XML, we worry about syntax. Remember, syntax just means the words, the way we send things. Semantics is the meaning behind it. XML is mostly just the syntax, which means when I tell you send, you know what it means. When I say receive, you know what it means. Okay. SOAP, also we call it message inside an envelope. It's used for communication, etc. So it's an envelope, an optional header. So all of them have a header and a mandatory body, an actual container. All your emails, etc. typically is done using SOAP. Okay. SOAP message is unidirectional. That means it's not a conversation. You send a message, it's one direction, and then if they want to reply, that's a different SOAP. And it's kind of like when you go to your friend's house using Uber or a taxi, you don't guarantee the same taxi brings you back. You go with one car, when you're done, you take another one. That's why we call it unidirectional. Okay, we also have what's called WSDL, okay, which we discussed this already. It's a web service interfaces. It's just interfaces. There's a lot of definition and binding on services, all that stuff we built into this one, like endpoint. When I want to communicate, is it from whom to whom? Okay, and binding means network protocols. Remember when I say bind, this is not a network class, but am I using TCP or am I using UDP? Remember, just very briefly, it's not part of the class, but TCP means uh, every protocol, everything I send, you have to check the checksum and send it back to me. UDP means not. Let's say I ask for you to send me a movie. Okay, it divides it maybe in 1 million packets of 2K. But when it sends it to me, some bits might get lost. So with TCP, they compute the checksum and then they send it to you. You compute the checksum. If they matches, then you receive the whole thing. If not, you ask it to resend it. That's called TCP. Now with UDP, you just send it. You don't check the checksum. Well, the benefits of UTP is it's very fast, but the bad part is you might lose bits. How many times you listen to a movie or watch a little, listen to a piece of music online, and the bits are lost. Like all of a sudden it's perfect, and then all of a sudden, this is because using UDP, it's better to send it fast. Now, if you send it TCP, it's going to be really slow, a lot of pauses. So TCP is really important when you send legal documents because you don't want to lose anything. But when you send the whole movie, speed of transmission is more important. Okay. UDDI, also called this one Universal Discovery Description, etc. This is called Yellow Pages of Web. It consists of 3 parts: information about the organization that publishes the services, description information about each service, and technical info to link services to implementation. It's kind of like plumbing. You need to know where the plumbing is, their phone numbers, address, okay, what kind of service they provide. Always they fix your plumbing, they fix your toilet, they fix your, etc. And what kind of technical links to implement. What okay, I'm within 30 miles, I'm open Monday to Friday, so what descriptions you're going to provide. All of these needs to be stored. It needs to be very brief though, because it is really metadata. It's not, for example, if you're publishing, let's say you're a restaurant, you're not going to give your full menu to UDDI. You're just going to say, hey, this is Macaroni Grill. We are Italian restaurants. We are located in Arlington. Here's your phone number. You don't want to give them all the description of the food because it takes too much room. It's just during binding, you could always tell them that one. Okay, so original dream or the original idea was one global registry. This is actually going back to Bill Gates and Steve Jobs days. The ideal was they have one global registry for the entire universe and Earth, but then they had real reality kicked in, many registries with different levels of visibilities. Because remember, there are two problems. One is some information are not prudent for everyone. Some of them needs to be a little bit more secretive. Okay, like your grade at the university should not be public to everyone. So that's one thing. But the second one is just the volume of these things. I don't think in 1970s or 80s they predicted, or 90s, this over explosion of data that nobody thought. These social networkings, Facebook alone generates 1 billion lines of information per day. So registries can hold this one. So even though the dream was to have one big place, but the reality actually says we're gonna have many, many little ones. So far we talked about what is a service description. Then we discussed various things about services, like autonomousness and how to discover it. And then I discussed some technology. Now this last part I want to focus on what we call it service-oriented software engineering. That's different from that non-service oriented software engineering. So this is, compare this one. This is actually one of my exam questions last time, but it wasn't the multiple choice. When you don't have service-oriented service engineering, non-service oriented, what do? You always come up with requirements, then design, then implementation, testing, delivery to the customer, right? This is sort of a waterfall. Even if you do it in Agile, you do the same thing in little pieces. But in service-oriented architecture, remember, the recipe I just told you is all about cooking at home, but I don't want to do full design. I don't want to do full implementation. I want to go steal, beg, and borrow from other people. This is called service-oriented architecture. So how do I do that? So now we are going to do it this way. So if waterfall was requirement, then design, then implementation, then testing, then maintenance, service-oriented is this one. One we call it service-oriented analysis. So I'm going to analyze to find out what's there. I need payments, I need requirements, I need login, I need search. How many of them are out there available? Because I want to go steal, beg, and borrow. I don't want to do it. Okay. So that's the first thing. Then I'm going to do service-oriented design. Now that I know these pieces are there, I'm going to design my system using other people's parts. Okay. Then I'm going to do service development. I'm going to develop it, but I'm not going to write a lot of code. I'm just going to get your search plus your payments plus these groups, for example, I don't know, sorting, and I'm just going to put them together. So here, development for me doesn't mean write it. It's just like making a call to a restaurant. I'm just going to get it. Then I'm going to do service testing, but the testing means now I'm going to put it all together and test it. And then I'm going to do what's called service deployment. That means now that I have everything, I'm going to deploy it to the customer, which is kind of like delivery to the customer. And then I'm going to do administration. That means I have to maintain it now. If something's broken, or sometimes you have to pay fees. I have, for example, a news in one of our products, but we rented this thing from Reuters. So that means every month we have to pay subscription to Reuters. So this is called administration of that service. Okay. So this is then replaces that one. Notice how it changed from requirement design to service-oriented analysis, and service-oriented design. Everything has a service on top of it. In other words, instead of buying groceries and then coming up with a recipe, and this one I'm going to say, okay, let's look how many restaurants are near us. Let's look who wants what kind of food. Let's look, okay, now that it is, and maybe half of us want a steak, half one of us wants vegetarian, so let's call two separate restaurants. Let's go this one, right? So terminology, okay, I probably have 6 or 7 slides. The rest of it is more diagrams I'll briefly cover, but some terminology, service-oriented environment, okay, so or service-oriented ecosystem. So remember, the key thing we want to talk about, environmental ecosystem. Know what it is. When you talk about Italian food, it's an environment, it's an ecosystem, it's a restaurant, but you exactly know what's an Italian food versus a steakhouse, right? So the ecosystem is restaurant, but the environment is probably that. Or for yours, it could be ecosystem, might be, Android applications, or maybe, I don't know, websites, right? So then we have business process and supporting services. So what are the business processes? For example, we need to know application services at the application level. We also need business services, a lot of tasks and entities, and a lot of hybrid. So for example, let's think about if you're trying to get applied to the university, first you need to apply to the university. But when you come here, you need to apply for the university, you need to have a GRE and you need to have TOEFLs if you're international. But then when you come on board, you need to have a lot of tasks, which means a lot of taking a lot of courses. And then a lot of entity centric. Your courses are in the computer science, the courses are in the biology department. So you could see the application is for everybody, but when you get in, you have to go to a pocket. That means you can't say, well, I was admitted to UTA, now I can't take courses anywhere. No, you can't. You cannot go to the nursing department and say, I'm at UTA. It's tough, UTA, but you're in this entity. So we are very entity centric and we are very task centric. You're only allowed to take these computer science courses in this department. No, occasionally we do hybriding. That means, okay, I know you're a computer science student, but I'll let you take an electrical engineering class, or I'll let you take an, biology class because you're interested in bioinformatics. So that is sort of the terminology. So remember, what is hybrid means a mix of things, entity versus task versus application. So these are some terminology I want you to get used to. Okay. So this is sort of looking at this one, hybrid, business, infrastructure. We look at things from an order. Let's say if you want to get admitted to the university, it's an order. Like when you go to a restaurant, what do? Okay, you order. Okay, so let's look at a restaurant first of all. You walk to a restaurant and then you have an order. Okay, so your order is to order food. Now, then it goes to the sort of waitress staff, right? They come, take your order, make sure everything is okay. They take your order, then they deliver it. But then at the end of it is the cook and kitchen. So not necessarily you are allowed to go to the kitchen on the bottom. So even though you're ordering a service, that doesn't mean you can't go to the kitchen and watch the cook. Or when you go to a bank to get a check cashed, that doesn't mean you can't go to the safe and watch them get the money out of safe. There's a middleman always in here. So this is sort of and often it's a hybrid service. You when you go to a restaurant, you may not say, well, I only want this food. You may want to have something to go as well, right? So think about this is the way we look at it. Or when you come to the university, first you have an order. What's your order? I need to get admitted to the university. So you have some middle processes. You're gonna have your, ETS send your test scores. Your university will send your transcripts, all of that stuff. So these are different businesses. Does your university have anything to do with our university? They don't. They are different business. For example, a university in India might send you a transcript electronically to UTA, okay, or ETS will send you GRE scores. Now you want to get admitted, but all of a sudden ETS is involved, electronic test services. Your university is involved, and maybe a bank in your back home is involved because they need to finance your education. Now, when you're there, now it's the back office. Now you come here, you start taking courses, and you issue your degree. Okay. So now the strategies for this sort of life cycle organization, we could put them top down, we could put them bottom up, we could put it as an agile strategy. So for example, okay, a top down, so notice here top is red. You look at from what I want from the top. I want to get a degree. Okay, so based on this one, now you fulfill things. You go and do the rest of the stuff. When I want to have a rest, order food from outside. Oh, I'm having a party at my house. So it's top. Then you go fulfill it. Call the restaurant and fulfill that thing. Right? Sometimes, and so pretty much when you go from top down, you start filling from the top all the way to the bottom. Not that important of a slide, so let's skip through this one. Now, bottom up, notice what we do this one. Still, your purpose is the service. This hasn't changed. But I'm not going to look at it from a service point of view. I'm going to look at what I have. Oh, what I have is I have taken a few courses and I've already done a GRE. Can I put them all together, see if I can get a degree out of that one? So that is called the bottom-up approach. So sometimes you want to design a car, so that's top-down approach. And then you start putting things together. Sometimes you say, oh, I got a couple of tires here and there's a door there and there's a seat there. Well, maybe I can build a car based on that one. So see, both of them are sort of different view of things. Not that important. It's kind of like think of a vacation. Sometimes you come top down. It says, I really want to go on a cool vacation to Hawaii. So it's top down. Then you start thinking about the details, car, etc. Airlines. Sometimes you could say, oh, wait a second. I have a friend in Vancouver, and then I haven't seen him in years, and I also have some free American airline miles. Maybe because of these things, I book a ticket to Vancouver. Ultimately, the goal is the trip, but remember, with this one, we went bottom up as opposed to a top-down version of things. Okay, uh, so agile is actually something that we do little things at a time. So whether you do it top down or bottom up, it doesn't really matter. So we always have this service oriented analysis, design, etc. Let's do little thing at a time. And that's actually, as I said, it's not that important. This is not an agile class, but maybe a little bit of a hybrid is good. Maybe not so much top down, not so much bottom up, maybe somewhere in the middle, and just do little things at a time. Because with agile is, okay, maybe I have a view on the top, so I'm gonna come and do a little bit of an analysis of what do you expect. I expect to build a car, or expect to go to a trip to Vancouver. Well, it requires this one, I need to rent a car, I need to do this one, etc. So you go there, and then you're gonna say, well, when I get there, I gotta stay at the hotel. Now, another cycle. Let's look at the hotel, Motel 6. Do I need to get a room on board, or do I need to use Airbnb? So you deal with Airbnb when you're there. Now you're there, you want to go visit some sites. So you just, instead of looking at the whole thing, you just break it down to little pockets. So that's sort of also an agile strategy. So service-oriented analysis basically is the process of determining how business automation requirements can be presented through service orientation. That is a very important slide. So I'm gonna maybe two more slides and we sort of wrap it up as far as the exam goes. But the key thing is I need some services, but my key thing is automation. How can I automate some of these processes? So not every time I have to do everything from scratch, right? So these are some examples I'll give you as far as that goes. Okay, so this is a very important slide. This is slide and the next one. So think about it. We have some service operation candidates. Okay, so one of the key things I want to do is box these things up. Okay, and I'm going to look at them as sort of these two are related to one, this three relates to one. So for example, appropriate for intended use, or identify the primary issues, define the primary stuff. So um, let's say I want to, okay, this is something I do on day-to-day business. So I want to say, how do we do the goals here? So let's go back here first. Okay, let me Oops, I'm going the wrong way. Okay, this is better. All right, so notice here there are basically 3 steps. I'm going to cover this, and pretty much the rest of these are examples. Okay, so first of all, let's cover this, and I'm going to come and use an example to make it clear. So I have a lot of sub services. Maybe you want to take a vacation, or maybe you get admitted to university. So these are a lot of sub services, but how can I make this one to sort of an automation so it gives me a better resolution or better way to put things together? So first of all, I have basically some kind of an analysis. So step one, I have some kind of a service oriented structure. I want to make sure I don't want to reinvent the wheels. I want to use something that's out there. So I want to define the scope, identify automation, and then use some candidate services. Okay. So first of all, define analysis scope. Okay. So basically, here's this box. You have a goal, you want to define the analysis scope. Okay. So what I'm going to do here, I'm going to break this down. Remember, the S is the sum of a lot of subset services. Okay, so I'm gonna first of all say, okay, to do this task, I'll break it to have a vacation, I need to have an airline and then hotel, and to do this one. To get admitted to UTA, I need to have TOEFL, GRE, complete courses, etc. Okay, so you first come up with these. This could lead to some sort of what's called process agnostic service oriented, which means really this is neutral to your process of how you're doing this services, delivering business specific ideas. I don't care how you do this one or who are your services, you have to be sort of neutral and apply to anything. Is this for admission? Is this for graduation? Okay, so after I break down the services, this is everything is done. This is a very important slide, by the way. This is called order fulfillment. So you start with an order. Is this getting money from an ATM, or ordering something on Amazon, or is it something getting admitted to university? I have a starting point. Then I'm gonna have, this is called purchase order. Getting admitted to university is like a purchase order. Getting ATM is like a purchase order, right? So I receive a purchase order. So next I need to validate it. Is everything cool? Is the GRE scores are okay? If everything is okay, if it's not okay, send it back. Say this is not a good order. If it is everything is okay, then I'm gonna transform this purchase order to the next step. Oh, this is a good purchase order. Let me get the credit card now. And then I import it, and finally I deliver that project. So pretty much you collect all the pieces, and then from this one, if everything makes sense, give the admission to the student. If it doesn't, reject the student. Okay. So step two, automation part of it. So what is really already implemented? How can I automate this process? Okay, and I'm going to talk a little bit about the automation in a second for you. So in here, maybe I can do these parts of it that are good automation techniques. Automation means, can I redo the parts over and over and over, okay, to fulfill what I need to do? And last one, I need to do some model services. How to compose a service. How can I call this one a service, for example, that from now on I'll offer this to the customer? Okay, so just remember these 3 services that I was telling you about. So for example, a purchase order could be, when you place any order, I can look at it this way. Remember, if I look at it this way, that's really convoluted. But if I look at it this way, now it's a lot easier. I need something. I need to get admitted to the university, or I need to go on a vacation. So I receive my purchase order, I validate it. Okay. Then if everything is invalid, toss it out. If it's valid, do it. That's this way. So this is basically, so let me give you some example. Let me just go here and talk about this. Okay. Let's say this is a very perfect example, but it can apply to banking, to vacation, anything that you order from outside. Okay, let's say UTA. We get about 3,000 people apply for MS to computer science every year. Okay, 3,000. As a grant advisor and a subcommittee, if you are going to review each member, guess how long it's gonna take? Each member takes about 30 minutes times 3,000 applicants. Okay. So this is 90,000 minutes. That's going to take 6 months of 4 people. Well, we don't have that kind. So let's say, how do I do this one? How can I use service orientation with these 3 steps? So first of all, I have a lot of sub-services. One, I have your application. Then I have your transcripts. Then I have your TOEFL scores. Then I have your GRE scores. And then I have my needs score. Like I need to know, I need 400 MS applicants because you cannot admit everybody. Now I'm going to make this one to groups. I'm going to say this is for your ETS scores like TOEFL and GRE. This is for your transcripts, for example. Okay. So what is the next part that I've talked about? So that first item was to recognize it. Remember, this is defined as scope analysis. So this is all the services I just told you about. But the main thing is to make it into components. So these are all independent. I made it to this one. Now, I have certain rules. Okay, this is how we do this one. In order to get admitted to the program, you need to have a GRE of say 300, maybe 145 in verbal and 155 in quant. If you're international, you need to have say 84, 85 in TOEFL and up, okay? Plus your GPA needs to be 3.0 or higher. Let's just use these 3, okay? No, it's really easy. I'm gonna say, and maybe one more, maybe you have some deficiency classes that are, maybe you don't have 2 or 3 of the required classes. So the first run, I'm gonna say, go reject, accept everybody automatically who satisfies this condition. So the system automatically, without me even looking at it, this automation takes over and says, what is the GRE? Oh, 320, excellent. TOEFL, 95, excellent. GPA, 3.6, excellent. And then does he have all the courses? Yes. All of a sudden from 3,000, 300, 400 people are automatically in, right? Without any problem, maybe 30% are accepted, right? Because they're the cream of the crop. I did not even look at it. The system automatically picked it. Okay? Now I'll run the second batch. Now let's reject people who are maybe violating at least 2 of these. So you don't want to violate by 1, because what if somebody has a 3.8 GPA and everything is perfect, but the only thing that they are violating, maybe the GRE is a little low, or maybe we have a lot of EE students in our program. They have very good GPA, very good TOEFL, very good GRE, very good grades, except they're missing a couple of deficiency courses. So I'm going to say from these 4 or 5 categories, if they miss more than 2, and it was not only they don't have a good GRE, they also have a low GPA, or they're missing a lot. If there are 2 or more, automatically reject. So what happens, all of a sudden, I started from 100%, whatever the pool is, 30% cream of the crop, they're accepted. And then 50% or 40% are rejected based on these rules. So all of a sudden, I started from 100%, my automation took care of 40% rejection, 30% acceptance. Now I only have 30%. And you know what? I further automate this one. I don't want to send them a letter. I have a canned letter for the admission and a canned letter for the denial. For the admission says, congratulations, we are proud to have you, from the following semester. It's the same for everybody, but also for the rejected ones. I'm going to say, unfortunately, we have many conditions like GRE and test, and you did not satisfy 1 or more of it, because I don't want to specify, because some of you may have a good GRE, bad GPA, etc. But I use a canned answer that says, hey, you did not meet all our requirements. And in comparison with the pool of applicants, you didn't fall. Now, very nice. And the moment you rejected, this letter automatically goes there without any human interaction. Now I have only, from 100%, I only have 20 or 30% to deal with. Now that's a manageable number. Even that one, I can have sub rules. I'm going to say, okay, now if the GRE is slightly low and GPA is slightly high, but no course deficiency, automatically admit. So this is the third layer. So all of a sudden, the last 30%, even 15 or 20% of it, they get admitted or rejected based on the sub rules. Once again, the same thing. So I'm only left with 10%. Now from 3,000 a year, I reduced it to 300. I can do that, not a problem. I have a committee of 4, so that is manageable. And that's very accurate because computers don't lie. So notice what we do. We first took the services and make compartment odds of it. Compartment for ETS score, compartment for your transcripts and availability of common courses, and compartment for your GPA and level of your university. Now I have three compartments. Then, so that was the first item we did here, right? So this is basically this one, breaking it down, scope, and this is breaking it down to this sort of generic, sort of agnostic centers. When it's agnostic, I don't look at your GRE, I'm looking at GRE as a general, I'm looking at GPA as a general, okay? And I have some business-specific rules that I put it on, okay? What was the next one? Okay, the next item was automation. So here I am going to identify how automation works. Here are the rules. Rule one, let's get rid of the bad ones, perfect ones, accept them. Let's reject the old ones, the ones that are bad, and then maybe the second set of rules, and then finally do this one. And finally, basically the model candidate services. Now this level of services, I'm going to find it whether it's task, whether it is individual services. I'm going to look at them and analyze this one. That is the power of service-oriented architecture. It's a very, very nice agnostic process which helps you set up various different things, and that is what I wanted to make sure that everybody knows what that means, right? So that is the key things that. Okay, so last item I want to talk about, so pretty much this covers our services. We talk about services, services structures, and other things. Okay, as far as exams and other things, that's all I want you to know. And remember, this is the simplicity that we're getting into. Okay, so we take this, all these operations, student applies, student provides, I validate it. If everything is good, I go this route. If it's bad, I go this route. Along the way, I do a lot of automations, right? But no, it's much easier to look at it this way. Very simple, very pockets of things. Purchase order comes. Purchase order means admission to the university, or borrow money, or get ATM, or order things from Amazon. Okay, I receive it, I validate it. Then if it's a bad one, answer, and it was not admitted to the university. If it's a good one, admit to the university. Done, right? So this is basically the last one. Now the next few slides are important, but as far as test goes, they're not that important. So we basically talk about a lot of different examples in the business. Okay, so you talk about task-centric. I used one of the cream of the crops for you, but these next ones are just the same things, just breaking it down a little bit more closer. I just told you about the GRE. So sometimes the rules affects other rules. For example, you could say, well, if GRE is low, but the GPA is high, but then the other courses are there. So you could sort of, that's why we're sort of crossing all of these things. If this is valid, but this is invalid, but the validity is a little bit over, but it's totally up to you of how you set things. So as I said, this is the whole thing falls into, you always start from a top level order, whether it's admission requests, or whether it's a purchase order, or whether it's sorting number, or having an Android app, you always come from there. And when you talk about service-oriented architecture, there's two layers behind you. It's like going to a restaurant. A middle layer that takes your order, and the bottom layer that handles your order. And the key thing is, often these are two different entities. So you want to make sure that these entities are different. So these are, we have a lot of UML, Unified Modeling Languages, for showing these things. This is, for example, sequence diagram of events. This is a little bit, two details. So up to about slide 45, that's what we need to do this one. So in summary, okay, services have a long, basically, history or telephony. That means it's been around for a long time. Most important characteristics are their dynamic discovery. That is very important. When you want to call a plumbing company, you need to dynamically discover that one, because there might be a new one since yesterday. Okay, SOA it's really a style, and it's very important. That means you focus on service, and remember what the concept is. You go from production to consumption, from purchasing the food and cleaning it at home, producing it yourself. You actually purchase that order. You go to a restaurant. So just restaurant analogy is the perfect one. And remember, in our history, that's how we transition. Remember, real life computers follows history. Think about this. Many years ago, 100 years ago, 200 years ago, there were no restaurants. People always just prepared the food themselves. But in the last 30, 40 years, we are full of McDonald's and restaurants, and then we have gourmet level restaurant versus low level restaurant versus fast food. But we are moving. So 100 years ago, 100% of the people fix food at home. Today, only 40% of the people fix food at home. I am sure 50 years from now, maybe not even 1% of the people fix food at home because it's too time consuming. Okay. Now, the same thing with computers. When we started in the 50s, everything was built from the start by everyone. But then we are moving more and more and more like restaurants. We're more using other people. And actually kind of makes sense. How many million people need to write search? How many million people need to write login or payment? Well, you know what? There's enough of it written. Why waste time, right? Let's just use some of the good ones that fits your needs. Just plug it in and go with this one. So the key thing is this is so web services is very syntax based. Remember, all of these is possible because of one thing and only one thing: internet. The reason I find things very fast and open source, and I find your search routine and Jeff's payment is because of the internet. So the key design is service-oriented software engineering, is the way we change our view toward putting things together. I don't go from the home cooking, I go from analyzing what's out there. How can I get your things? How can I connect them together? And this basically differentiates it from a traditional waterfall software engineer or even agile, which means I do things. Even agile, you do it yourself, right? But when we go to service-oriented architecture, you could not use the stuff yourself anymore. So this is a slightly longer chapter, but we are pretty much done. So this is the end of chapter 19, basically referred to as service-oriented architecture, or in short, we call it SOA. Bye-bye.